So guys, as you can see, we have two LEDs here, one on the left, one on the right. One LED brightness starts from the highest and then it starts to go dimmer, and one LED starts from the dimmest and starts to go brighter. See, this one starts bright and then goes dimmer, this one starts dimmer and starts to go brightest and then starts all over again. See, this is how we are using the dual PWM channel. Each LED is connected to one PWM channel. So let me give you a quick go through the code. See, these are some variables we are going to use. These where we initialize the PWM pins, then we started the PWM channels, and then we set the initial state for the variable. P1 will start from 0, P2 will start from maximum, that is 255 duty cycle, and then we set the do while loop to repeat, and do while loop terminates at 255 because max PWM is 8-bit. So here we set the turn time to be incremented by 1 with each repetition, then the P1 increases and P2 decreases, and then we set the duty cycle, and that's all. This gives us this result. Welcome to learning microcontrollers. In this video, I'm going to show you how we can control the brightness of two LEDs at the same time using two PWM channels of the PIC16F877A microcontroller. So guys, our PIC16F877A microcontroller have only two PWM dedicated channels, like they are 2 pins. So we will use these 2 pins at the same time, like we will have 2 LEDs. In this tutorial, we will have 2 LEDs connected to 2 PWM pins of the PIC16F877. Then we will program it in such a way that one LED will start from off state and then it will keep on going brighter. And then once it becomes brightest, it will start all over again. And at the same time, another LED connected to the other PWM channel will start from the brightest. Then it will start to go dimmer, and finally it will go off. So this will be the demonstration of using the dual PWM channels of the PIC16F877A simultaneously. So let's get started. So guys, this over here is our PIC16F877A microcontroller having 40 pins. It's a DIP version. These are the 2 LEDs we are going to use. As you can see, each LED have 2 pins, one longer, one shorter. Longer is always the power and shorter is always the ground. For the shorter pins, just short them and send them to the common ground like this. And for the longer pins, you will need a resistor. It is a current limiting resistor. Its value can be from 100 to 500 ohm for the maximum brightness. If you go higher values, you may do it, but the higher the value of the resistor, the dimmer the LED will be by default. So I recommend use a 220 or 330 ohm resistor. Now guys, for the longer pin of the lower LED, connect the one end, connected to the one end of the resistor like this. From the other end, now from the other end of this resistor, you cannot connect it to any available digital input output pin. You only have 2 pins for the PWM in the datasheet, known as the CCP1 and CCP2. You will either connect to C1 or C2. Pin number C2 is a PWM pin, and similarly for the other LED, connect the longer pin to the one end of the resistor. From the other end of this resistor, connected to the other PWM pin, that is C1. Now these 2 pins, pin number C1 is the CCP2 pin, and pin number C2 is the CCP1 pin. Pin number C2 is the PWM1 and PWM2 is the pin number C1. So in the datasheet, you may see that CCP2 and CCP1. So this is the PWM1 and this is the PWM2. So only 2 pins in the PIC16F877A are dedicated for the PWM generation using the MIkroC libraries. If you use any other pin, then you have to go other type of programming. You cannot use these libraries on other pin. So now let me introduce you to the hardware before we move on to the programming. So guys, this over here is the hardware. These are the 2 LED, 1, 2, and then over there you can see it's just my trainer board as usual. There is a PIC3 connected, so we will power up the circuit using the PIC3. There's a very simple circuit over there. Rest is just a trainer board, so don't get confused by it. So this is our MIkroC for PIC. Let me zoom in so you guys can see better. So you can see that I have version 7.6.0. You may download the latest as well. I also have a lecture on this, how you can download the latest version for free from the official website. Legal, totally legal. So please do check that. Click on new project. This window pops up, new project wizard. Click on next, write the name of the project, PWM dual channel demonstration using LEDs. Okay, I call it now 1. Okay, and the microcontroller I have PIC16F877A, and the crystal I have is 20 megahertz. I click on next and finish. Now guys, this over here is the window. Before you do anything, click on save to save your work like this. Now guys, go to the right, you have these libraries, expand the MIkroC libraries, then system libraries, and down you have the PWM. Check mark this box, expand it. Here you have this PWM1 INIT command, double click on it. This window pops up. Copy this command, only this command, go back, paste it in the one-time loop. Now this command over there initializes the PWM1 pin with a 5 kHz frequency. You may change the frequency, but for our LED brightness control, this is enough. Now give some initialization delay, not necessary, but I always suggest you give it in the one-time loop, because sometimes there may be a problem with the working of the module. So do the same for the second channel, just make it PWM2. Now we have to start the PWM, so go there, there's a command called PWM1 start, double click on it. Here you go, this is the command PWM1 start, copy it, this starts the PWM module. Now go to the forever loop, write down while 1, forever loop starts here, ends here, and paste it here like this. And now do the same for the channel 2 like this. Now this is channel 2. Again, some initialization delay will do fine. Not necessary, but I always suggest you give it if you are using the PIC12, PIC10 or PIC16 series. They are not recommended for PIC18, but you may use them over there as well. So these are the initialization delay. These are the commands to start the PWM. Now PWM is started. Now we need to set the duty cycle. For duty cycle will decide how much bright the LED have to glow. So there you have this command PWM1 set duty cycle. Click on it, go down. Okay, there. This command, just copy it, paste it here like this. Now this is the command, and this will set the duty cycle like 192. It means that, okay, let me show you the description as well. So you may see the description of this command. Sets the PWM duty ratio. Parameter duty takes value from 0 to 255. Now 0 to 255 in our case will be 0 to 5 volt. So where 0 is 0% and 127 is 50%, 255 is 100%. This means that if we are giving 5 volt, this means that PIC is run at 5 volt, then the PWM generated will be, the output voltage will be 0 at 0. 127 means 50%, it will be 2.5 volt, and 255 means it will be 5 volt. So LED will be like dimmer at 0, and it will be maximum at 255 value, and in between it will vary. So that is how this is going to work. So go back. Now this is what we will give ourselves. I give it some name. Okay, also write the command for the second PWM channel as well, PWM2 like this, set duty cycle. Now guys, over there we just give them some integer values, so because we want to vary them. So I call it like int p1, that is for the PWM1, sorry, p1, and int p2, integer p2. We take two integers, so I make it p1, I make it p2, because these are the variables which will change. Now for the p1, I give the initial value as p1 equals to 0. This will be start from 0, and p2 equals to 255. So as told you earlier, we will program it in such a way that one LED will start from 0 off state, and then it will keep on going brighter, 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 and finally it becomes brightest, and then it will go all over again. And second LED will start from the maximum brightness, and that it will keep on going down, 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 and until it becomes 0. So these are the initial states. So we know that 255 is the maximum brightness, 5 volt, 0 means 0. So now we have this. Now to do the repetition, we will need a do while loop or any for loop or whatever you prefer. I will use the do while here, do while, and now we need a variable, another variable to set the counter. So we take a variable called int cnt count. So count is also equals to 0 by default, so make a cnt equals to 0. So here count is equals to count plus 1. With every repetition, counter is increased by 1 like this, and inside it we write the condition like keep on repeating until counter is less than equal to 255. So that's perfect. Counter is less than equal, it will keep on repeating the loop until counter is equal to less than 255. So this is by default 0. So we copy it here. So P1 is equals to P1 plus 1. So it will keep on increasing. So by default it's off. Now it will start to go brighter, brighter, brighter with every repetition. And the second one is the brightest. So it have to go down opposite. The P2 second channel will go like P2 minus 1. So it will start from 255 and then it will keep on decreasing by 1 with every repetition. Now the speed will be too fast. We load down the speed. We use some delay ms. Like each step, there will be total of 255 steps because we have set the counter to maximum 255 value. So we also have the PWM maximum 255. So this one will start to from 0 to 255. It will keep on going brighter with every step, and this will go dimmer with every step. Now we give a delay because this loop will be too fast. I think 50 will do fine. So we give a delay of 50. So it will be like not. We will adjust it if it's still too slow or too fast. So every step will take like 50 milliseconds. So we have 255. You may like count it. Or another way of giving the delay is that you give it between commands. That's better. So we give a delay of 10 milliseconds between each command. This will also add to the overall delay and will also increase the efficiency of the code. Like this. Okay. We give a delay like this and also make it 10. So total is 10, 20, 30, 40, 50. So still it's 50. So that's a better way. So now we have our code written. So we build this code. Click on build. Okay, we made a mistake here. Just press enter. Why it came here? I didn't wrote it here. Okay, okay, that's perfect. I build it again, so it's built. So what we expect from this code is that our PWM1 and 2 are initialized. Then the PWM1 starts, PWM2 starts, counter is equal to 0 by default, P1 is equal to 0, P2 is equal to 255. Then here we have a do while loop, repeating 255 times and increments by 1 with every cycle. So total we have, now P1 increases by 1, P2 decreases by 1. So PWM duty cycle, PWM2 duty cycle. And after the loop is completed, it will go all over again, setting all the conditions back to initial. So I built this code and we open the PIC16 programmer tool. This is the PIC16 programmer tool. I have a video lecture on this as well. You may check it out, how to download and install it and use it. So PIC16F877A is the one we are using. Click on file, import hex file. This is the file we just created. Click on write. Okay, the new file is being written. Let's go to the hardware and see what happens. So this is the hardware and these are the two LEDs. Okay, let it write the two file. Okay, we will power up the circuit using PIC3 because it do not require a lot of power. I click on. Okay, you can see both the LEDs are working. Okay, if it's difficult, let me dimmer the screen. Okay, this seems better. Make it more dim. Okay, now that's perfect. Now see, one LED keeps on going brighter, one goes dimmer. Now the speed is too slow. See, now this started from the brightest and is going dimmer. This started from the dimmer and it is going brighter. See, and once this loop is done, then it starts all over again. See. Now this one is the, now you can adjust the speed as well. Like I change the speed, like I think it's slow. I make it faster. To make it faster, just lower down this delay, just make them 5. All of them I make 5. Like this. Okay, now we build this code. This will be like faster version of the same. Click on write. Okay, the new code is being written. Go back and wait. Okay, it's written. Now see, the same thing is happening but at a different speed. One LED starts from brightest and goes dimmer, and one LED starts from dimmer and starts to go brightest. So that's how you play with the PWM. These are the dedicated pins of the PIC16F877A. You have a PWM module. We are using that. You may use the other pins as well, but that requires some special technique to use them to generate the PWM pulses. I will show you in some other video. So guys, this is it. I hope you guys learned something from this video. So we'll see you in the next lecture. So goodbye until then.